Welcome. Today we are going to learn to find the rate of change of a linear function given 2 points. Now the rate of change is always constant, and the rate of change is also considered to be the slope. So for instance, let's look at the points 9, 9 and 4, 2. If you wanted, you could absolutely take the time to graph those 2 points. And I'm just going to roughly do it. If I do the point 9, 9, I'm going to go out to 9 and up to 9, which is going to be way out here somewhere, point 9, 9. And then if I graph the point 4, 2, again, I go out 1, 2, 3, 4 and up 2, wherever that may be, that point is 4, 2, right? What we want to calculate is the slope or rate of change of that line that goes through those 2 points. Now, to find that slope or rate of change, what we need to do is we need to know how far away those points are vertically and how far away those points are horizontally. In other words, we find the distance between the 2 y values, the distance between this 9y value and this 2y value. So we would do 9 minus 2 equals 7. We would find the distance between this x value and this x value. And so we would do, for this side right here, we would do 9 minus 4, which is 5. And then the rate of change is the rise over the run. So it would be 7 over 5, 7/5. Now, a lot of students like formulas. If you'll notice, I took this second y value and I minused off the first y value. So slope, which a lot of times mathematicians refer to m in the equation y equals mx plus b. So we're finding slope. M is the second y value minus the first y value divided by, right, this run, right, the second x value minus the first x value. So x2 minus x1. A lot of times mathematicians will abbreviate this with what's called the capital delta, the change in y over capital delta, which means change in x. Again, I'm just showing you these in case you ever come across these in a textbook or somewhere else. You'll recognize that delta, meaning change in y, which is y2 minus y1. The delta x is the change in x. It's kind of a little simpler or shorter way to write y2 minus y1. And so given these 2 points, I could have very easily, and by the way, it doesn't matter which one you consider to be the first or second point. So I could have labeled this x1 and this y1 and this x2 and this y2. So my first point and my second point, I'll get the exact same slope of 7 over 5, even if I take the 2 minus off the 9 and put that over the 4 minus off the 9. Because then what I'm going to get is I'm going to get a negative 7 over a negative 5, and then the 2 negatives cancel, giving me a positive 7/5, which is what I got when I did the graph. Now, just be very, very careful, though, that you always go the same direction. If you consider this one the second point, always take these values and minus off these. If you consider these the second points, then always minus off those. Don't accidentally go 2 minus 9 on top and then 9 minus 4 on bottom, because you minus the opposite direction. Now, you're more than welcome to take the time to graph, but sometimes it gets harder to do that because the numbers get obviously a lot larger or further off. But still, it's not hard. You're just roughly doing it. I would just graph the point negative 6, 7. So negative 6, 7 would be like right here somewhere. Then I'd graph the point 58, negative 25. Well, positive 58, negative 25, that's down here somewhere. And I'm just going to have some slope like this. And again, I'm going to try to find the rise and the run. What is the distance between the 2 y values? Again, change in y over change in x, or y2 minus y1 over x2 minus x1. So I'm going to do the negative, for this one, I'm going to do the negative 25 minus the 7 over, and then I'm going to do the 58 minus the -6. So be careful with signs. 58 minus a minus is going to be +6. Again, think about it this. I'm adding this little distance here, this distance of, actually it's this way, this distance of 6 here to this positive distance, right, of 58. So again, I get a -32 over 56 plus, or 58 plus 6 is going to be 64. And then they always want you to reduce. I have a negative over a positive. My final slope is negative. By the way, I'm going downhill. Remember that as well. Up here, if the slope is going uphill, it's a positive. Going left to right, uphill is a positive. If the slope is going downhill, going from left to right, going downhill, the slope should be negative, which I got, a -32 over 64, which, by the way, reduces to -1/2. Right? So, again, let's do one more. Again, here, again, very large numbers, lots of negatives in there. There's still nothing wrong with us going, okay, -96 up 32, -97 up 91. That's going to be a very steep slope, by the way. Going to be a very steep slope, and it's going to be downhill, so I know it's negative. But again, I'm just going to go that second y value, 91, minus the first y value, 32, over the second x value, -97, minus the first x value. Now be careful here, I'm minusing a minus 96. Well, 91 minus 32 is going to be 9, 11 minus 2 is 9, 8 minus 3 is 59 over, well, -97 plus 96 is going to be -1. So my slope is actually just -59. I don't need to put over the 1. You could if you wanted. But you don't need the over 1. You could just say it's -59 is my slope, which is a very, very steep slope, which makes sense if I'm going from a -96, or sorry, if I only move over 1 and I move up a whole bunch, right? If you have questions, please bring them to class and I will help you then. By the way, I would recommend writing down this formula here if it helps and referring to that as you're doing your homework.